Good afternoon, good morning, good evening, Python WebConf. I'm excited to be here. This is actually my first virtual conference that I'm speaking at, so I'm excited to try this format. My talk today is entitled Monitoring and Testing Web Applications in the Wild, and my name's Sam Clarke. So yeah, let's dive in. I'm actually going to start with a little story, a little anecdote. Anybody who is a car owner out there might be familiar with this orange warning light on the dashboard. This is an orange warning light that tells us that there's some issue with our car's engine, but we don't know what. We don't know the severity of the issue. So if I'm driving my car down the road, I don't know whether I should pull over immediately, whether I should get home first. Is this a problem that needs an immediate attention? This doesn't give a great deal of insight into what is actually going wrong. So a few years ago, I bought one of these little gizmos. I think I picked it up for $5 or $6 on Amazon or eBay. And this is an onboard diagnostic ODB2 type vehicle interface. And this actually plugs into that ODB port on most modern vehicles. You usually find that somewhere around the steering column. And what this thing does is it allows access to the log data in the car's engine, the vehicle's engine. Now, this has Bluetooth on board, so this allows it to be paired with a smartphone and a variety of mobile applications you can download, which will give you access to the data in real time. And what this did basically overnight turned my engine from this black box into a steady stream of real-time data and standardized fault codes. And not only did it allow me to understand what was happening in the engine at any given time, it also allowed me to learn much more about what was about the vehicle's engine based on researching those fault codes as they came up. Now, this didn't turn me into a qualified mechanic overnight, but what it did allow is for me to have a much greater understanding of the complex system, which is my vehicle's engine. Okay, so with that little preamble out of the way, my name is Sam Clarke. I'm a senior developer at AgFunder. AgFunder is a venture capital firm that was founded in 2012 with a focus on investing in food and agricultural technologies. One of our principal products from AgFunder is our website at agfunder.com. And as well as detailing our current investment portfolios, it also is a place where we share bespoke market reports to the world and to the industry. And when these reports are released, we can typically expect our web traffic to go up orders of magnitude above baseline. And so it's really important that we have robust systems to monitor the web traffic on our servers, to know what is going on at any given time, and to make sure that that website that stays up. And so it's crucial that our website performs well during those high traffic loads. Okay, so a quick summary of what I'm going to talk about today. First of all, I'm going to cover why monitoring matters, the value of monitoring your web applications. I'm going to dive into some of the aspects of a web application that can typically be monitored. We'll discuss what happens when something inevitably goes wrong, and we'll look at a few takeaways. And because this talk is pitched at a beginner audience and upwards, it's important to get a few definitions out of the way for people that may not be familiar. When I talk about dev, I'm talking typically about your laptop at home, your work machine, anything that is really not exposed to the public where the work of creating a web application happens. Production is your user-facing part of your system, is what the users interact with, and usually critical that performs well. Monitoring is any form of continuous analysis that we do on a web application. A metric, something atomic that could be measured, And load is, when we're talking about load, we're talking about quantity of requests to the server. Okay. So your app will fail. As most of us who are software engineers come to understand, failure is really an integral part of our work as software engineers. And getting used to failure is really part of our job. Having said that, failure is a spectrum, everything from an undisclosed HTML element to your server box melting and taking your product offline. These are all types of failure. And as software engineers, as we grow in our careers, I feel that we start to learn how to predict, prepare, and act on these failures. So one of the reasons, why did I prepare this talk? So this is a quote that I'm familiar with, you may also be familiar with, attributed to Helmut von Moltke the Elder, who was leader of the Prussian army in around the end of the 19th century. No battle plan survives first contact with the enemy. You may have heard either this quote or a paraphrasing of this quote. But basically the insight that embodied in this quote led to Moltke's desire to evolve beyond deterministic battle plans in favor of resilient strategies that could adapt to real battle situations as they occurred. In essence, the best strategy is that which left some room for flexibility to account for the real world. So what we're really talking about here is when your product being released to the wilds of the internet to real users is sometimes when the greatest test happens. As a developer, we inevitably move from developing our app in a closed environment to the vagaries and wilds of the internet. Another quote that I like, that is really not attributed to anybody, but I think if you're a developer, you've probably either said these words at some point or thought them, or at some point in your career you will say them, that it worked in dev, that something worked in development, and releasing it to production, releasing it to the internet, was to expose it to a lot of unforeseen circumstances. And it's really to capture the essence that development and production are quite different environments. And it's difficult to predict exactly what will be tested in your application before you actually observe it in production. Yeah, so how does development and production differ? And you know, why should we consider those to be quite different beasts? Well, you know, debugging in development is debugging in production is generally a much more opaque process than debugging in development. In the development, you can often watch a bug unfold. You can reproduce a bug quite easily, whereas in productions, often what we're doing is trying to reconstruct the circumstances surrounding an issue as it came up. We're trying to do some archaeology and figure out what was happening before this issue arose. And often those production bugs are not so straightforward to reproduce. So you can watch it play out again and again. Also, moving from a development environment to a production environment often involves lots of different layers and different technologies that in development you just don't experience. You could be dependent on some network latency between servers, for example. Third-party APIs that were mocked in development are actually live in production. Also, the production architecture may be vastly different to development. If you're using containers or large amounts of servers, excuse me, authentication, it may be quite a different place for your app to live. And this is not the focus of this talk. This is an aside, but I think it's worth mentioning, especially for users that are just getting into web development and producing web applications online. Staging environments really go a long way to closing that gap between the development, which is a very artificial environment, and your production architecture. Ideally, you want to have a staging environment that it resembles production, but obviously is not exposed to end users. And this allows you to do a lot of testing, rollouts, scaling, load testing, things you wouldn't want to do directly on a production environment. Okay. So imagine a scenario: you've created a web application. It works in development. It seems to fly. It's performant. You have really good coverage in your unit tests. You even have a continuous integration server set up. You're getting green dots. You're deploying to production. Everything seems fine. So is there really a need to monitor your web application if all of your testing is saying you're good to go? Just release it to the internet. What could go wrong, right? So there are many reasons why monitoring of the web application is a good idea. Principally, if we're monitoring our application in real time in production, it allows us to catch those problems before they become critical. Often when a problem is likely to arise in a website or a web application, there are early warning signs, and it's super useful to get to catch these before something moves into into a much more critical area, like taking your product completely offline. It also allows your engineering team to respond much more quickly when there is an issue. So rather than a bug on your website or some issue with your application manifesting for days, or lying there for the weekend until you come in on Monday morning, it allows your team to be notified and hopefully get a fix out there before users actually encounter that issue. It also, excuse me, it also allows us to create this historical record of performance, which is to say we can capture how the application is performing over time and really pinpoint where improvements can be made and where improvements have led to increases in performance. So basically you have this, this narrative surrounding deployment of your application. And that can drive product development. It can drive what your engineering team needs to work on, and what improvements and updates need to be made in the future. Also, the goal here is to increase observability and insight via feedback. And what I mean by that is that it allows us to have a very clear understanding of how your application is performing, because we're getting data coming back to us from the web application. And by feedback, I mean real data. And we get that insight because we're getting data back. Feedback in the form of data is obviously preferable to something like this. On the right-hand side here, you can see a disgruntled user that has decided to get in touch and tell us how bad we're doing at maintaining our website. This is really not the type of feedback that you want to see, and by the time you received this email, you've probably missed a great deal of issues. This type of feedback means a user has encountered a critical issue and decided to get in touch, but how many users encountered this bug or this issue before this user and didn't take the time to get in touch, and just walked away from a website? For us at AgFunder, this could be a potential investor, and this could represent real tangible revenue that is not coming to the company now. As engineers, we really want to be aware of a problem and have a fix in place before it gets to this stage. Okay, so hopefully I've made the case for monitoring being of value and being a good thing. So let's take a look at what are some of the aspects of a web application that we can typically monitor. One of the most fundamental would be the uptime and availability of your website. For example, if you have a landing page, that's the first place where users go. It's probably critical to your company that landing page stays up and stays accessible. So having a service that can ping your landing page is the first step in knowing that everything is okay. Also think about what other resources in your web application you need to have, you need to be aware of the uptime for. For example, is there authentication services? Do you have APIs that either used internally or used by the public? And again, it's critical to know when those go down so your engineering team can be contacted and get a fix out there. Load is looking at your application, how it performs when you start to scale, when users are starting to hit your landing page, your web application, your web service. And that could be really important to be able to predict how performant your website is going to be when you actually get popular. Logging. This is a deep area where we could talk about a lot about. This is basically where a developer can introduce log statements to your application code and get meaningful information about either when things go wrong or just the general running of your application at the code level. Metrics are, again, anything about the system or your application that can be measured and creating a data series based on that. And performance really captures all of the above. And it is a more like a macro metric, basically, that could be used to gauge how well your application is doing over a longer period of time. You can then be detailing performance wins that you want to tackle in the future, and historically you can see how your engineering team has managed to squeeze more and more performance and more resilience out of that application. So at this point, I might be tempted to give you some suggestions of the best tools out there for monitoring web applications. However, I'm not going to do that. And there's various reasons for that. One, I have not tried all of those applications. Also, the best fit for your need. It depends very much on what your web application looks like and the tech stack involved. Also, naming names right now is probably going to date this talk very quickly. What I'm happy to do, though, is after the talk to share some of the tools that we use at AgFunder and suggest some good ones to get started with. Okay, so let's talk about some metrics. So metrics are usually a way of generating data points, and they take different forms. It could be a counter, for example, number of successful, number of failed requests or logins. It could be a gauge, which could be something along the lines of latency or network speed. And these type of data points are generally collected in a time series way, which allows the engineering team to follow over set periods of time how that particular metric is changing. And these metrics can be very useful for triggering your alerting mechanism, which we'll explore later on in this talk. It's for example, if you have a threshold of number of drop requests, or if you have a resource that is being used up and you want to be alerted when that gets to 80 or 90%, these are typical uses of metrics in a web application stack. I want to quickly flag up a couple of terms that you may come across in respect to metrics and monitoring: Blackbox versus Whitebox. So Blackbox really is observing the application or observing the system externally. And you're really not getting a lot of detailed information about what's going on within the guts of the system. More, you're getting indicators that things are good or bad. And this can be analogous to, say, walking down a street and seeing how many lights are on in houses at night and how many are off. You can see the light is on, and that indicates something about possibly the presence of people inside the house, but you don't necessarily know what's going on. Whereas Whitebox is a term that tries to encompass the internal situation. So, for example, you might be able to you might want to know how many people are in that house, how many people are on the first floor or the second floor. And thinking about Whitebox and Blackbox, It also harks back to, remember that orange warning light on the dashboard? That's typically a black box signal. That's telling me, hey, there's something wrong, but I'm not going to tell you what it is that's going on. A white box is my ODB interface that plugs in and says, hey, the reason why you're getting this error is because of X. Okay, so let's move on from metrics and talk a little bit about logging and how to use logging in your web application. Okay, so typically the first question that engineers that come to start using logging have are, what is it that you should log? Really, when you're thinking about what to log, you should be thinking about how well do you know your system? How well do you know your code? Where is it that you want to get insight and feedback from your application? For example, you might, one of the starting points might be, hey, I want to know if our authentication and registration system is working correctly. Can we log when somebody has an error signing up? And when you do log that, can we have some information that tells us who it was and what they were trying to do at that point? Think about the format that the logs are going to take. Are they going to be in plain text? Are they unstructured, for example, in server logs, or structured in a way that can be parsed either by a human or by a computer system? Are they stored in binaries like in systemd? It's important to think of what is the consumption mechanism for these type of logs. And that kind of leads on to those last 2 points, which is, where do those logs get written to? Are they just on a server somewhere, on your single server? Are they hooked up to a third party and aggregated so that the engineering team can go and view them in a dashboard? And also think about, again, who is the consumer of these logs? Is the members of your team, is it, are they being passed automatically? Do you have some other system for reading in those logs and taking action? If you're writing those logs by hand, does the information in those logs make sense to the rest of the team? Are you using internal abbreviations, for example, that seem to give you information but don't necessarily communicate much to anybody else in the team that needs to pass through those logs? Because when something goes wrong and you're looking through those logs, you really want to be digging down into the important information as quickly as possible. And so to use logging effectively, there's no substitute for really understanding your code. When you understand how your code works, how a user flows through your system, or how a request flows through your system, that's where we should start before we start adding log statements everywhere. And when you understand how your system works and how your code works, it's a lot easier to reason about where you really need to add logging straight away to start getting the feedback you need. And it's important to understand what the levels of logging, so that those can be used effectively, and the rest of your team knows how to read that type of log. Excuse me. And then those log levels as well are going to impact how those logs are handled by a host and how they pass by monitoring software, and then obviously later your team. And also think about the information that's contained in those logs. Do you have context to effectively debug a problem? If you're logging in an exception block, do you have variables or prior information that is useful in that log to understand exactly what was going on prior to that exception being raised, or prior to that issue being encountered? And is that enough information to reconstruct the circumstances around that issue, and to hopefully understand what was going wrong or how to reproduce it? Okay, I'm not going to spend a great deal of time on Python logging here, but I will flag up a couple of tips. And these are also things that I didn't know at the beginning when I started logging, and I've also seen other engineers be unaware of, even and more experienced engineers. Use the dunder name as to name your logger, to configure your logger. It's much easier to refactor code when you use this as a variable rather than trying to give it some fancy name, and then 6 months down the line your code changes and the name that you gave your logger is no longer relevant. And it's much easier then to trace through the system where those logging statements came from when it's configured like this. Also, you can easily get tracebacks within a log message using exec_info equals true. And this is a good way to get that context that I talk about, especially when you're logging in an exception block. Logging and metrics. So logging and metrics are not opposed to each other. There's not a pick one and go with it kind of scenario. Having both logging and metrics in the system are valuable complements to each other. Now, structured logs can deliver much more context sometimes than a single metric. As I said, you can have those tracebacks and variables contained in your log messages, and it's obviously that's more rich than a single data point. Also, from those structured logs, it's relatively trivial to turn that into a metric if that's what you require. And and in some ways, industry definitely is moving more towards using logging as a real-time data stream in place of metrics in some ways. So that's also possible as well. However, metrics generally come with a constant overhead, which means that as you scale, as requests and traffic increase, taking those metrics that are being gathered generally don't scale in the same way, whereas logging will. And logging is not free. There is a price to be paid, which is obviously parsing and writing those log statements to a file. And this can increase as your traffic increases. So there's definitely a consideration to be made there if you start adding logging to a high traffic web application. Okay. So as we discussed, your app will fail, things will break. That's to be expected. What we want to know is when things break, we want to know immediately when things do break, and then to be able to take action based on that. Okay, so let's talk about alerting. So we're going to, now we have our metrics, we have logging, we have a way for our system to communicate to our engineering team that there is an issue happening. And so who in our team should be alerted when something goes wrong? And it's important to consider this before you just launch it into production and then put the CTO's email onto the alerting profile. We should be thinking about what is appropriate for your team. The people that should be alerted that there's an issue should be able to take meaningful action. It's not just a fancy email. It's something that needs to be acted upon. How you are alerted also bears consideration as well. Email can be a fine way to tell members of your team that something's wrong, but often emails will get missed. People have different filtering set up on their emails, and often it's not checked in, email is often not checked in real time. Slack is another option, PagerDuty, text message. It really depends on what is the best communication platform for your team, and how do you get information to the relevant person as quickly as possible. When you do notify somebody in your team, are they aware of how to escalate it if the first responder is unable to fix the issue? Do they know the next person to call? And again, is that person going to be effective? Are they able to solve this issue? Also, think about how how you determine how urgent this issue is. If you've been woken up in the middle of the night, it should be because that issue needs immediate attention. If it's not, if it's something that can be taken care of tomorrow or Monday morning, for example, think about how that urgency is communicated through the alerting process. When your first responder, your engineering team does respond, is it clear what they can do to fix the issue? Is a redeploy necessary? Is something needed to be reset? Are there other engineers that need to be looped in to deal with this issue? Okay, so you've been alerted, you've been woken up, your engineering team has fixed the issue, and or the engineering team is on site to fix the issue, I should say. Now, do they have enough context to debug the problem? And this is where your logging statements will prove either useful or not so much. If there's enough context in those logs, in those metrics, it should allow the engineering team to quickly get to the root of the problem and pinpoint what was happening prior to the issue and hopefully what caused the issue. Now, when you're thinking about installing an alerting mechanism, think very carefully about what types of alerts are getting through and how frequently your team is being alerted. If you're getting, as an engineer, an engineering team, 10, 20, 50 messages per day that something is not working quite right or something that your system thinks you should be informed about, it's easy to desensitize your team. It's easy to inure them to these error messages. And that's a very dangerous place to be, because as soon as we stop paying attention to those messages, that is when errors will start to fly under the radar. So make sure that the frequency of alerting is tuned to the responsiveness of your team. Also, when something has been fixed, is this a real solution to the problem? Is it a band-aid that gets us to the next working day when there's more engineers on site? And also think about a structured post-mortem around any issues that arise. Is there documentation that needs to be written? Is there possibly even a blog post that could be encompassed that could encompass this type of issue? How does the rest of your team understand what was the issue, how it got fixed, and why it won't be an issue again in the future? Okay, so we've talked about metrics, we've talked about logging, and I quickly want to dive into traffic and load testing. So being able to monitor the traffic of your website, obviously it is super useful to create this historical record of visitors to your web app, to your website. And that can help in debugging issues after the fact. Seeing traffic spikes, for example, and then correlating them with your metrics data or your logging statements at the same time can reveal a lot about when things broke and exactly why they broke. Load testing your application or website before you get to the point of release into production can be critical in determining how much traffic you can actually support. So if you're expecting, to be able to support 10,000 users in requests in an hour, maybe you want to make sure that you test that, you can actually support twice that amount or 10 times that amount. Build a comfortable buffer so that when those spikes hopefully inevitably happen on your website or your web application, that you can be confident that that is a level of traffic that can be supported by your production architecture. Obviously, load testing, say your landing page, some of the high traffic parts of your website is critical and fundamental, but also think about some of the other aspects of your application. It may be an authentication API or some other service that you provide to the public that it maybe not be a landing page, but is critical to your business. and it going down or it being not performant is a real problem to your business's bottom line. So think about what other parts of the application can be tested under load. And just load testing is great, but there's more to do there. If you already have some metrics and logging set up, this is a great point to put your website, put your web application under load, and then look at the metrics that are being gathered, and seeing what happens to those performance metrics as the load increases. If you start to see a request being dropped or an increase in errors, then you can correlate that to basically the real world scenarios. How many errors are you able to support before things become really problematic, for example? Or does your latency and response time start to really slow down to the point where even though your website is still up, it's not really serving its purpose anymore? Okay, so a lot of the aspects I mentioned apply here to single web applications or websites, often to monolithic architectures. But of course, it's 2020, and a lot of people moved to microservices and splitting applications up into very small pieces. And the logging frameworks sometimes are inadequate at this point. I'm not going to spend a great deal of time on this aspect, but for architectures that involve a lot of microservices, using those logging frameworks might actually give way to other types of monitoring and tracing. In particular, actually tracing. So the ability to trace a single request throughout the system that wouldn't be captured by a single logging framework, but would basically allow us to add an identifier to request, and as it goes through lots of different microservices, trace it and track it, and when things actually do go wrong, understand where that request initiated, what was happening in other parts of the system which may be completely disconnected or in different tech stacks, and construct again that historical narrative that allows us to effectively debug. Okay, so that's a lot of stuff. So what I really want to impress upon you at the end of this talk is that we can consider application monitoring as a method of continuously testing and probing the health of our web application and our websites. It's really a complement to, and not a replacement for, robust testing coverage. But beyond this, collecting metrics over time allows us to engage in true data-driven development. That is, using data to influence decisions in product development and maintenance of our web application. Okay, and just in the last 5 minutes, I would like to just summarize some of the things that we've touched on today. So first off, before tackling logging and metrics, we really want to have a good grasp of our code, how our application works, and what it is that we want, what kind of feedback we want to get from our application. And what do we want to know, and what information will help us to effectively debug and improve upon our web app. Creating quality logging allows us to reconstruct the context around an issue, around a bug, and provide or create a narrative around what happened. When instituting logging and metrics and alerts, think about what your response policies are going to be. This is not all about code. This is about sitting down with your engineering team and saying, how are we going to deal with issues when they arrive? And what are our policies around alerting, fixing, postmortems, etc. It may be tempting to start thinking about how you're going to roll your own tools to deal with monitoring and debugging and logging metrics, but there is a great deal of third-party SaaS options out there, and I would definitely advise get started with something that's off the shelf. You know, even if it's a free tier, and get started with that. Usually they're very easy to install and get up and running. And rolling your own really is not the first step. Yeah, so you're finding that third-party solution. So with that, I could say with robust monitoring and logging, we can really do better than a single orange warning light on the dashboard. Okay, I think maybe there's a few minutes left if we do questions, either in the gallery or in Slack.
Absolutely. I will toss one that I see in Slack over here and zoom to you.
Okay.
Just 1 second. There you are.
Sorry, do I Q&A here?
The chat button at the bottom next to share screen.
I'm sorry, I'm just not seeing that on my system here.
Sure. I can just read it out to you.
Yeah,
extensive monitoring has an impact on performance. So how do you find a balance between monitoring that provides good metrics and not slowing down performance too much?
Yeah, so that depends a little bit on the system you're running. Again, as I said, metrics, especially if you're using a third-party agent, often the impact is relatively minor, and I would encourage you to start using those tools and worry about the performance once you have that up and running. And again, you can test your own application to see if that's a performance hit. And then, as I said, logging is an area that we probably have to pay more mind to the performance hit because you're writing logs. But again, if you're already in the process of starting to measure things in your web application, then introducing new technologies shouldn't be a barrier, because again, you can continue to measure performance, whether that's the first paint on your website, or a request cycle, or a latency. Then you should be able to also be measuring as you're introducing more and more tools.
We have another question here from Vincent. What do you suggest for third-party log monitoring tools?
Again, depends on your system, and there's a lot out there. I don't want to name too many names, but have a look at things like Loggly, Splunk. There's many that will aggregate your logs in different ways, and it really depends on what works for your team. But having one centralized way to get into your logs very quickly is key.
Absolutely. I don't see any more questions over here in Slido. And I see someone typing in Slack. Let's see here. There's a little bit of a delay, so we'll wait just a second to see if they have a question here.
I'll just say now, also, I'm going to be hanging out in Slack for the next little while, so any questions that come up, feel free to hit me up in Slack.
Absolutely. Okay. Cool. Well, while they type, I'll let you answer those in Slack then. It looks like they're still typing. I will go ahead and stop this stream right on time. Perfect. Thank you so much. I know we're all going to virtually applaud for you here. So if you need Sam, he will be hanging around in Slack. And then if you'd like, you can also join in the gallery as well.
Awesome.
Awesome. Thank you so much.
Thank you all.